Hi class, let's take a look at example 2. Now example 2 is, one of the special angles, but we are looking at a radius of 1. So remember that this represents r comma theta, and they have to tell us that the coordinate points are polar. So I would actually tell you the following are polar, otherwise we could misunderstand that as x comma y, and they're technically not the same. We would have to use the actual formulas here in order to find the correct relationship. So this particular one, it's going to represent an actual radius of 1. So I'm just going to say that this is 1, this is technically 1, and your actual circle is going to be going around this. And the coordinate point is an actual pi over 4. So technically at a 45-degree angle about here, and that would be sufficient. So we're just looking at the coordinate point as r comma theta. This is technically 1 comma pi over 4. And that's it. We're just putting the dot on the approximate position. Like I said, you don't have to basically include a bunch of circles. I just want a dot on the approximate coordinate point. The second portion is they want us to express these polars as rectangular, just so that we have it in perspective, or we may need to come up with some equations that it's easier just to turn them back into polar or rectangular. Now your x value, x is equal to r cosine of theta. Your y value is r sine of theta. Whoops. And in this case, we're looking at 1 cosine of pi over 4, and technically 1 sine of pi over 4. So these are the special angles. You're looking at square root of 2 over 2 and square root of 2 over 2. As you change these to decimal, you're going to get, I'm just going to use 2 decimal places. Actually, let me use 3 just so that you guys have it. So 0.707 and 0.707. So our final solution is that in r comma theta, or in this case 1 comma pi over 4, this is the same as x and y, which happens to be square root of 2 over 2 over, well, actually comma square root of 2 over 2, which approximately this is 0.707 comma 0.707. Let me fix this. So that would be it for this particular one. Once again, you're looking at a coordinate point that happens to be at the end of a circular radius 1, but at an angle of pi over 4. So that would be it.